So today I want to go over how to simplify square roots. You might have seen this in Algebra 1, but they might have showed you a different way, okay? What's important is that you know your perfect squares. So I got a list of perfect squares over here. These are perfect squares, okay? So like for example, let's say you're taking the square root of 36. Well, 36 is a perfect square. The reason it's a perfect square is because 6 times 6, so 6 squared is 36. So the square root of 36 would be just 6. If I took the square root of 256, well, look at the list. Is 256 on the list? Yes. What's the square root of 256? 16. All right, so it's important that you know your perfect squares. So I suggest that you maybe take a screenshot of this list here so you can use it. All right, so we want to simplify each expression and leave it in radical form. Or you want to leave it so it has a square root in its answer if it's not a perfect square. So let's simplify this first one. The square root of 50. So my first step is to look at my list. Is 50 a perfect square? So is 50 on this list over here? It's not. So now what you want to do is you want to find the biggest perfect square that divides into 50. So the biggest number from this list that goes into 50. Well, that number is 25. So what you can do is you can write this as the square root of 25 times the square root of 2. Because 25 times 2 is 50. What is the square root of 25? 5. So the square root of 50 reduces down to 5 square root of 2, or 5 radical 2. That's your final answer. That's simplified. The reason it's simplified is because the number that's under the radical doesn't have a perfect square that divides into it other than 1. 1 goes into everything, so that doesn't count. So you always want to make sure the number under your radical doesn't have a number from this list that divides into it. If it does, you can reduce it. If it doesn't, it's reduced. All right, so let's try 147. Is 147 on my list? It's not. Okay. What divides into 147? Well, I don't know the factors in 147. So what I'm going to do is I'm going to just start dividing 147 by some numbers. I'm always going to start with 2. So let's see what 147 divided by 2 is. So just get out a calculator. 147 divided by 2 is 73.5. Is 73.5 a perfect square? No. So let's take 147 and now divide it by 3. 147 divided by 3 is 49. Is 49 a perfect square? Yes. So the biggest perfect square that divides into 147 is 49. So I can break the square root of 147 down to the square root of 49 times the square root of 3. 49 times 3 is 147. And then what's the square root of 49? 7. So my answer is 7 square root of 3, or 7 radical 3. Okay? All right, let's try C. Hopefully you're getting how to do these now. 200. Is 200 on my list? Is 200 a perfect square? It's not. So let's find a perfect square that divides into it. Well, 100 divides into it. 25 divides into it. 4 divides into it. Okay? So 200 has 3 perfect squares that divides into it. So if it has more than one perfect square that goes into it, you always want to choose the biggest one. We always want the biggest perfect square that divides into it. So I'm gonna use 100. So I'm gonna break this down to the square root of 100 times the square root of 2. Square root of 100 is 10, so my answer is 10 radical 2, or 10 the square root of 2. 98. The biggest perfect square that goes in 98, what is it? 49 goes into 98 twice. 49 times 2 is 98. The square root of 49 is 7, so my simplified answer is 7 square root of 2. So that's how you simplify radicals, okay? Now, let's use this concept to solve quadratic equations. We have solved quadratic equations by graphing and by factoring. Well, graphing and factoring might not always work, okay? So we have this other method. It's called the square root method. Now, the square root method doesn't work on all quadratic equations. It only works on quadratic equations that are in the form ax squared plus c equals 0. Okay? If you remember, this is the standard form of a quadratic equation. You can use the square root method when it's in this form. So when there is no x term, and there's only an x squared. So if you have a quadratic equation in which it doesn't have a linear term, an x term, then you can use the square root method. So again, to use the square root method, it has to have only an x squared. It can't have an x squared and an x. So if you look at all these equations I have up here only has an x squared. So I can use the square root method on them. So what you do to use the square root method is you get the x squared by itself. So on this first example, A, I would subtract 15 from both sides. So I get x squared is equal to 87 minus 15, which is 72. Now the reason it's called the square root method is because once you get the x squared by itself, see how I have just an x squared over here? What you want to do now is take the square root of both sides. The square root of x squared cancels out and you just get x. Now it's important that you remember to do this. When you take the square root method, what you got to do is you got to put plus and minus on your answer. So x is equal to plus or minus the square root of 72. That's my answer. But just like we did on the first slide, you want to make sure your square root is simplified. 72 is not a perfect square. So I got to find the largest perfect square that divides into 72. And that's 36. 36 goes into it twice. So the solution, or the roots, to example A would be x equals plus or minus 6 square root of 2. That has two solutions. It's just a shorthand notation of writing it. The two roots are 6 radical 2 and negative 6 radical 2. But if you don't want to write it out twice like that, you just put a plus and minus in front of the number. All right, let's do B. So to solve for B, we would first add 17 to both sides. So we get 2x squared equals 25 plus 17 is 42. Then I would divide both sides by 2. I get x squared equals 21. That's what x squared is. I want to know what x is. So now I take the square root of both sides. These cancel out, so I just get x. And whenever you do the square root method, you gotta put this plus and minus on your answer. So it's the square root of 21. Now, if you think about our perfect squares, we got 1, but 1 really doesn't count, that goes into everything. Then we got 4, 9, 16, 25, right? So these 4, 9, and 16 are the only numbers that are possible that can divide into 21. Does 4, 9, or 16 divide into 21? It doesn't. So 21 doesn't have a perfect square that goes into it. So you can't reduce the square root of 21. It's already simplified. So this is your answer. X equals plus or minus the square root of 21. You just leave it like that. All right, let's try these last two examples. So C, we would subtract 19 from both sides. We'll get x squared equals 46 minus 19 is 27. Take the square root of both sides. So x is equal to plus or minus the square root of 27. Can the square root of 27 be reduced? Does 27 have a perfect square that divides into it? It does. 9 goes into it 3 times. So my final solution is x equals plus or minus 3 square root of 3. Right, one last one. D, let's add 81 to both sides. We get 4x squared equals 81. Divide both sides by 4. 4 doesn't go to 81 evenly, so just leave it as a fraction. Can't be reduced. So we got x squared equals 81 over 4. So now take the square root of both sides. Square root of both sides. When you take the square root of a fraction, the easiest thing to do is just break it down into 2 square roots. So this will equal plus or minus the square root of 81 over the square root of 4. And both 81 and 4 are perfect squares. So my final simplified answer is x equals plus or minus 9 over 2. Right, we're going to take it one more step a little further. Let's simplify these expressions. Alright? So let's do A first. On A, we got negative 7 plus or minus the square root of 16 over 2. So the way this is written is this is actually 2 solutions. Okay? What I mean by that is that plus and minus is just 2 different paths. So one of the solutions is negative 7 plus the square root of 16 divided by 2. And then the other one is negative 7 minus the square root of 16 divided by 2. That's what that plus and minus sign means. It's just a shorthand notation, so we don't have to write out this expression twice. Okay? So when you have expressions like this, what you want to do is you want to focus on your square root. You want to reduce the square root. Can the square root of 16 be reduced? Yes, that's 4. So what we have now is negative 7 plus or minus 4 divided by 2. Okay? When this happens, when the square root cancels out, you don't have a square root in your answer, and you have a plus and minus sign, you have to find, you got to use the 2 paths to find the 2 roots. So the 2 roots will be negative 7 plus 4 divided by 2 and negative 7 minus 4 divided by 2. So negative 7 plus 4 is negative 3 divided by 2. So one of the solutions is negative 3 halves. Negative 7 minus 4 is negative 11 over 2. So this is the second solution. So the 2 solutions are negative 3 halves and negative 11 halves. Alright, let's try B now. So again, we want to focus on my square root. Can the square root of 24 be reduced? Is there a perfect square that divides this 24? 4 does. It goes into it 6 times. So I'm going to rewrite this as negative 2 plus or minus. I still got my 6 on the bottom. What's the square root of 4? 2. What's the square root of 6? We don't know. So we leave it as the square root of 6. Now, this one, I don't want to write it out twice like I did on the first one because I have a square root in my answer. But These numbers that form on the outside of your square root, you gotta always look at those. If there's a number that divides into all three of those numbers, not just two of them, has to go into all three of them. If there's a number that divides into all three of them, you can reduce it. What divides into 2, 2, and 6? 2 does. So I can divide these all by 2. So that becomes a 1, that becomes a 1, that will become a 3. So my simplified answer for B would be -1 plus or minus 1 square root of 6, which is just the square root of 6, over 3. You can write that 1 in front of the square root if you want to, but you don't need to. There's my simplified answer. This 3 on the bottom cannot divide into the 6, because the 3 is on the outside of the square root, the 6 is under the square root. To cancel numbers out, they gotta be in the same location. They gotta be either both on the outside or both under the square root.